Hi everybody, what I'm going to do in these videos as requested is to show you how to do the ray diagrams again. I'm taking these examples from your study guides so you can kind of follow along with that, but I'm going to show you an example of all cases, so the spherical mirror, specifically the concave, the convex, the diverging, and the converging lenses, so you can see how to do these ray diagrams. Okay, so as you can see I have the example ready to go right here. And this is the concave mirror, and I know it's going to be concave because the way this object is placed is in the where the, how should I say, the object's placed so that the curve is going in toward the object. If it was going away from the object, that'd be a convex. So this is a concave, and it actually tells you in the problem that it is, I think, concave. There it goes. Okay, so first I need to figure out the focal point if it's not already given. That's very important. So let's do that. So we have a candle. It's 50 centimeters from the mirror here. And the radius of curvature of the mirror is 25. So remember, C is essentially R, which is 25 centimeters. Now, if you recall, the focal point is going to be R divided by 2. So our focal point is going to be 25, which is the radius, divided by 2. Sorry, I'm jumping ahead, because I know the answer is 12.5. Now, just for the ray diagram, I just need to know where that is so that I can use it to help me draw it. So halfway is the radius of curvature, and then halfway of that will be our focal point. So this is my F right here. Okay, so that's important to figure out because I'm going to use that to help me draw. So the first ray is going to go to the mirror, like that. And if you have a flat parallel ray and parallel to the principal axis, it's going to go and reflect through the focal point. So I'm going to do that. So that is our incoming, and then that's our reflection right here. The next one I'm going to draw is going to go through the center of the mirror. So that goes right to the center. And we pretend that's a flat mirror right at the center. So when we draw the reflected ray, it should be pretty much the same angle. So again, I'm doing this visually here, but it should be relatively the same angle. So that looks visually pretty good. So as you can see, when the two reflected rays, notice not these two, the incoming, the reflected rays, meets, they're going to create an image. So I just want to do the last, technically we're done, but I just want to do the last one to show you your options. The last one is you can go through the focal point like this and touch the mirror. When you do that, it's going to bounce back completely straight like that. So that will be where it will occur. So it looks like my angle of the green one is off. So let's see if we could try that one again, because these should technically all meet. Let me see if I could do that again. But that's the idea. So let's do that. Actually, I'll do the other one first. Make this work out better. So through the focal point, there, and then it goes straight back like that. I'm still seeing, maybe I did. It looks a little better now, actually. Let's go with that. Okay, so looks like we're good now. So the answer is the candle will be smaller, like that. Sorry, it's a bad candle. So what do we have? We have that it's inverted because it's upside down. We see that it's smaller, so it's height-wise smaller than the original, and since it's in front of the mirror, this is real. So those are the three characteristics there. Inverted, smaller, and real. Looks good. Okay, let's try another one. Again, this is from the study guide, and we're going to basically do the same thing. Now, I'm not going to do any calculations because the calculations are on the study guide, so just the drawing part. Just keep an eye on time too. Alright, so notice that the object is away from the curve, so the center mirror is away. So this is convex. Now with convex, what's going to happen is when I start off my ray right here, because of the nature of the shape, this is going to bounce off an angle like that. But if you remember in class, it's going to bounce off at a specific angle that's going to go through the focal point. So what I'm going to do is, because I'm using lines here, obviously it would be easier when you have a pencil, is that this is going to bounce in the same line as the focal point. So that looks about right. And again, I'm just kind of continuing my lines to make them look, that's good enough. It's not great, but okay. So the rule applies the same. So if I have a parallel line to the principal axis, you'll see that this will go off at an angle through the focal point. It just happens to be in the other side of the mirror. But this is the reflected ray right here. Notice I didn't continue the horizontal one. So for this one, since I don't have a focal point here, it doesn't work really well. I'm going to use the other one where I go through the center of the mirror. So I go to the center of the mirror. We say it bounces off at the same angle. So again, I'm eyeballing this to be like that. I'm going to go with that. That looks pretty good. But since these rays are not meeting, I have to go behind the mirror and continue this. So I'm going to continue this at the same angle like that. So when they meet, that's where our image is. So notice again, I continued this one and I continued this one. So it is going to be smaller than the object, as you can see. It's always upright. These are always the same. Upright. And lastly, since it's behind the mirror, it's virtual, which means it doesn't actually exist. It's our imaginations, is what our brains think. Remember, real means you could actually physically hold it, like the ring demonstration that I did. That's an image, and it's in front of the mirror. Okay, let's continue. Lenses are similar, but a little different. So the real and virtual definitions change because you want the real image to form after the lens, because that's where the refraction happens, or the meeting point of those rays. So if it's in front of the lens, it's virtual. But we're using similar ideas, so let's go ahead and do that. So the first one, if you look here, again, when it's converging lens like we have right here, I got to find the focal point. So a thin lens of that, focal point length 10. There we go. So that's our focal point. So I need to find that to help me do my ray diagrams. Good. The first one is you're going to take your ray. It's going to go through here, and I usually stop at the middle if it's not a line given. But anytime you go parallel through here with a converging lens, it will always go through your focal point. So it refracts, so it continues. So no reflection here. It just goes right through. That's what it does. So parallel in, through focal point out. So as you can see, I don't have the focal point in front of me, so I can't do the other rule. But the second rule is if you pass through the center, it transmits without any sort of, refraction. It just goes right through. So as you can see right now, I have a problem because my refracted rays do not meet on the front side of the mirror. So we're not going to create a real image, which means we have to go over here. So we're going to be creating a virtual. So what I'm going to do is continue this line until these meet. So I'm just going to eyeball it. That looks pretty good. And then same thing, I'm going to continue this line so it makes relatively the same type of thing. Oops. Let me redo that one. This is kind of hard. It's easier on paper. There we go. Actually, that looks... This will be perfect, but... Yeah, it's not perfect, but you get the idea. When they meet, that's where the image forms. So here we go, right here. And then I'll just do this in a different color. So the image I make is over here, like that. So notice that the image is going to be virtual because it's behind the object. So this is virtual, behind the lens. This is going to be upright. As you can see, it's the same, direction. Upright. And this is going to be virtual, upright, and bigger, magnified, like that. Now, converging lenses can do all three things. In other words, we can have virtual, real, upright, inverted, bigger, smaller. So they're going to be the ones that are tricky. Now, when you have a diverging lens, so this is a diverging lens, you're only going to form, just like convex mirrors, three things that are going to be the same each time. So let's go ahead and do this one out. So same idea. I'm going to start off, sorry my lights went off, they're on timers, with the parallel ray. What's going on here? Like that. Now, remember, as a diverging lens, technically this will go off in a at an angle away from any sort of focal point. But remember, this is special. It's going to go away at the same angle as traveled through the focal point. So if you notice what I'm going to do here, I'm giving myself a reference line at which this will go away, just like that. I keep doing that, but that looks close enough. So, refresher, as this comes in, this will go out like that, but at an angle that goes through the focal point like that. So we're going to use the second rule, which is at the center of the lens. It's going to go straight through, just like that. So you can see these two refracted rays do not meet, which means they're going to meet in front of the mirror, which you can see it does. So our image, I'm not going to draw Garfield. Sorry, Garfield. I'm not going to try. I'm just going to do an arrow and pretend that he was an arrow to begin with. But what you can see is that this is in front of the, this is on the same side of the object. It's not on the opposite side. So this makes it virtual because it's in front of the lens. You can see it's definitely reduced because it's smaller than the original. And then you can see that this is upright. Now this will always be true for all diverging lenses, regardless of where it is. So that's why this example is the main example. So that's how you draw the ray diagrams for all of them, for the spherical mirror, both concave and convex, and then the lenses of diverging and the converging. So diverging here, converging, concave, convex. Now keep in mind that this will change depending on where it is, in front of the focal point or far away. So these diagrams become different. So I only showed one example, the ones that are on the study guide. But remember, this one and the concave have multiple, outcomes that can change because of their shape. Okay, I hope you found this helpful, and best of luck.